Good day, I'm Maile Matsiba. Welcome back to our channel. We continue with our CIR 113 module and we continue with our semester test 1, the 2018 version. So we are also continuing with question 2 of the semester test 1. So today we're looking at question 2.3. This is actually the problem statement here. So I did read it in question 2. So you can just go check it out in the previous video. So today this is actually the question here. They say benzene, which is C6H6, is now used to dissolve the powder. If it is known that 0.922 kilograms of benzene is used, what is the final density of the solution? Also, they say assume mixing is ideal. So mixing is ideal, they basically means that the total volume or the total volume is actually the sum of the individual volumes. So yeah, now there's some information that we need here, and just a little recap. We know that initially there was an unknown powder in a 250 milliliter beaker according to this problem statement here. So and in question 2.1 and 2.2 we found some information on that unknown powder, including its mass and also its volume. So I'm not gonna do that again. So I'm just gonna do question 2.3 with the assumption of all the other information that we've already established, especially because 2.3 came in because I had commitments. I could not do it in the same video. So with that said, now they want the final density of the solution. So this is actually the solution that it's actually the unknown mass, rather the unknown powder that is actually dissolved with 0.922 kilograms. So for us to be able, let me just write down the equation of the density of the final solution. Let's start there. Density of final solution is equals to the mass of the final solution all over the volume of the final solution. So this is basically the equation for the density of the final solution. So now the question is, do we have the mass of the final solution, and also do we have the volume of the final solution? So at least we know that the mass of the final solution is actually the sum of the mass of benzene and also the mass of the unknown powder. And in the previous equations, or in the previous questions, we were able to calculate the mass of the unknown powder. So I'll just say the mass of the final solution is equals to the mass of benzene, which is 0.922 kilograms, plus the mass of the unknown powder, and we calculated the mass of the unknown powder to be 0.248 kilograms. So the total of the mass of the final solution is equals to, it comes to 1.17 kilograms. So it's easy to find the mass of the final solution. Now we need the volume of the final solution. From our previous questions, we have found the volume of the final solution. So now what we need is actually the volume of benzene. So, and we're gonna use the information here. We know we have our Sg here of benzene, and we know that we can just say the density of benzene. This is the standard equation. The density of benzene is equals to the mass of benzene all over the volume of benzene, right? Now we have the mass of benzene, which is 0.922, and we have the density of benzene, which is actually given as well, it's an SG of 0.876, so the density is going to be 0.876 kilograms per meter, 0.876 kilograms per liter. So we can just say, therefore, the volume of benzene is equals to, what is the mass of benzene? Is 0.922 kilograms all over the density of benzene, which is 0.876 kilograms per liter. And if you use your calculator, that gives you 1.0525 liters. So this is actually the volume of benzene. Now the volume of the final solution, let me write it in full. The volume of the final solution is actually the volume of the benzene plus the volume of the unknown powder. Like I said, if you want to know all this information about the unknown powder, go back to the previous video. So the volume of the final solution is actually the volume of the benzene plus the volume of the unknown powder. And because we are told that mixing is ideal, so that won't be a problem, which means the final volume will just simply be the volume of the benzene plus the volume of the unknown powder. And we know that the volume of benzene is 1.0525 liters plus the volume of the unknown powder. We calculated in 2.1 to be 0.13689 liters, and the total comes to 1.18939 liters. So this then becomes the volume of the final solution. And now going back to our density equation, we can just simply substitute the values. We say density of the final solution is equals to the mass of the final solution. We calculated the mass of the final solution to be 1.17 kilograms all over the volume of the final solution, which is 1.18939 liters. And that, if you use your calculator, will give you 0.9837 kilograms per liter. So that is basically our question 2.3. And just to explain something very important, in 2.1, I think 2.1, 2.2, where you can remember that the unknown powder was actually containing a 250 milliliter beaker, and initially there was helium that was used, or there was actually ethanol that was used in the beaker, and there was also helium replaced there was ethanol initially used in the beaker, and then they told us that, okay, now you can replace the ethanol and use helium, and all these two, helium and ethanol, we use them in the beaker. However, in this context here, it's important to understand that when you calculate the volume of benzene, it's 1.0525 liters, right? That already tells you that the dissolving here is actually happening outside the beaker. This is because the beaker can only take 250 milliliters, which is like 0.25 liters. It's a quarter of a liter, and the benzene itself is more than the volume of the benzene is actually more than 4 times the volume of the beaker. With that said, when you calculate this volume of benzene, that tells you already that the dissolving that is being talked about here is actually happening outside the beaker, right? So, and you should make your chemical engineering intuition by now to make that conclusion, to realize that if this is the benzene and then it has this Sg, or this density, then its volume is actually bigger, so we cannot have this mixing in the in there bigger. So I just wanted to explain that it's important to notice that. And as soon as you can conclude that, then you can actually calculate the density, because the density has nothing to really do with the container in itself. You can get the density without considering that container. So thank you for your time, and I hope we meet again in our next video.